Welcome to the FlowMax Regulator product training video. GE Energy's Mooney FlowMax Regulator is a loading-type, pilot-operated regulator that is primarily used in a pressure-reducing application. It offers bubble-tight shutoff and full capacity at differentials as low as 3 pounds per square inch differential. The FlowMax features a lightweight top-entry actuator, reversible plug seal, hand-removable filter element, and removable pilot cartridge. A pressure regulator assembly consists of two main components, the valve assembly and the pilot assembly. The valve assembly controls the flow of gas from the upstream system to the downstream system. The pilot assembly acts as the controller or brain of the device. It measures the pressure in the downstream system. It also provides the proper loading pressure to proportionally control the flow of gas through the valve body. This video will cover the basic principles of operation, installation, maintenance, and troubleshooting for the FlowMax Regulator. Here's how the FlowMax Regulator works, or its principles of operation. The principal function of a gas regulator is to control the flow of gas in order to properly supply the demand of the system. The basic components of a FlowMax pilot-operated regulator system are the throttling element, measuring element, actuating element, variable orifice, and fixed orifice. The throttling element is the plug and seat inside the regulator that constrains the flow of gas through the regulator from upstream to downstream. The measuring element is the pilot assembly, which is a self-operated regulator that measures pressure and responds to changes. The actuating element is the main diaphragm and actuates the throttling element to open or close proportional to changes in pressure. The variable restrictor inside the pilot responds to changes and controls the flow of gas to load the regulator main diaphragm. The fixed restrictor is the internal restrictor inside the actuator housing and relieves pressure differential from the main diaphragm. A pneumatic amplifier is the combination of the fixed and variable restrictors. The pilot controls the FlowMax through 3 stages of control: fully closed, partially open, and fully open. The fully closed position occurs when there is no demand for gas in the downstream system, which causes an increase in pressure. The pressure under the pilot diaphragm is equal to or greater than the force from the main spring. The imbalance of forces raises the pilot plug and stem assembly to seal and stop flow through the pilot. Because there is no loading pressure from the pilot, the pressure above and below the regulator main diaphragm is equalized through the fixed orifice in the actuator housing. The forces from the inlet pressure on the balancing diaphragm, along with the main spring force, are greater than the force of the inlet pressure under the plug. This imbalance of forces seals the regulator plug against the seat, stopping all flow through the regulator. The regulator is closed. The partially open position occurs when there is an increase in demand for gas in the downstream system, which causes a decrease in pressure. The decreased downstream pressure lowers the pressure above the main diaphragm. The force from the pressure under the pilot diaphragm becomes less than the force from the main spring. This imbalance of forces lowers the plug and stem assembly away from the variable orifice, allowing some flow through the pilot. This flow increases gas pressure under the regulator main diaphragm. The pressure below the diaphragm is now greater than the pressure above. The force from the inlet pressure on the balancing diaphragm, together with the main spring force, are now less than the force of the inlet pressure under the plug and the pressure under the main diaphragm. This imbalance of forces raises the regulator plug from the seat, allowing some flow through the regulator. The fully open position occurs when there is a large increase in demand for gas in the downstream system. In this situation, the pilot and regulator act much the same as when in the partially open position. The difference is that the pilot's variable orifice will open to allow enough flow to completely overcome the fixed orifice. This will increase the loading pressure under the regulator main diaphragm to the point where the plug raises off the seat until the regulator is fully open, allowing for maximum flow through the regulator. An increase in downstream pressure will allow the FlowMax to return to its partially open or fully closed position. Now that we've covered how the FlowMax regulator works, we'll show you how to properly install it. Enclosed with your FlowMax regulator will be a serial card showing the serial number and tests performed at the factory, and a parts list for the regulator and pilot if equipped. Inspect your regulator for any signs of damage. Verify that the serial number, size, pressure rating, and capacity on the nameplate are correct. Before installing the FlowMax, follow these general rules. Installation must be performed by qualified personnel and in a safe location. Locate the pilot sense line properly. The sense line should be installed at least 8 to 10 pipe diameters away from the regulator. It should be located in an area of stable flow, away from any valves, reducers, elbows, or other equipment that can cause turbulence, pulsations, or oscillations in the pipeline flow. Please see the Installation, Operation, and Maintenance Manual for further details. Single pressure reducing regulator configuration. Here is the procedure for startup, tuning, and adjustment that can be used or modified for your application. Ensure lines are purged and all connections have been leak tested before proceeding with startup. Back off the pilot adjusting screw to fully remove the spring compression. Slowly open the upstream block valve to pressurize the FlowMax regulator and pilot system. The FlowMax regulator should lock up or shut off with zero pressure downstream. If installed, fully open any hand valves in the control lines and the pilot supply line. Slightly open a downstream block valve or open a vent in piping downstream of the FlowMax regulator. Slowly increase the pilot spring setting until the desired downstream pressure is achieved. Slowly close the downstream block valve or vent to check the FlowMax regulator for lockup. Slowly open the downstream block valve to allow full flow. Startup, standby monitor configuration, downstream monitor. This procedure is based on the first regulator being the operating or working regulator, and the second regulator being the monitor regulator. Please refer to the IOM manual for piping schematics. Ensure lines are purged and all connections have been leak tested before proceeding with startup. Set operating regulator pilot spring at the maximum setting. The sense line shutoff valve should be closed and the sense line vent valve should be open. Set monitor pilot spring to the minimum setting. Slowly open the inlet block valve. Full inlet pressure should be present at the monitor regulator and the monitor regulator should be closed. If installed, open any hand valves in the pilot supply lines on both regulators. The sense line shutoff valve should remain closed and the sense line vent valve should remain open. Open a vent or downstream block valve. Increase the pilot spring setting of the monitor regulator until the desired monitor override setting is reached. Lock in the pilot setting. With some flow going through the station, close the vent valve on the operating regulator sense line and open the shutoff valve on the same line. Start to lower the pilot setting of the operating regulator until the desired outlet pressure is achieved. Please note that when the set point of the operating regulator becomes less than the set point of the monitor regulator, the interstage pressure will drop from approximately full inlet pressure to 2 to 4 psi above the outlet pressure at low flow rates. To verify that the monitor is working correctly, here are a few steps that you can take. With flow going through the station, slowly open the vent valve installed in the operating regulator sense line while closing the shutoff valve in the same line. The outlet pressure should begin to rise as the operating regulator goes wide open. When the pressure reaches the set point of the monitor regulator, the monitor should take control and the interstage pressure should increase to approximately full inlet pressure. Return the system to normal operation by reversing the process with the vent valve being closed while the shutoff valve is returned to the open position. The interstage pressure should drop to 2 to 4 psi above the outlet pressure as the operating regulator regains control. Once the FlowMax is properly installed, it is important to perform proper maintenance. This includes external and internal inspections. Start with the external inspection and check the regulator station itself for any mechanical damage. After inspection, the next step is to go through a routine checklist to ensure that the regulator is functioning properly. Start by checking the set pressure of the regulator. First, establish flow through the regulator station while observing the outlet pressure gauge to ensure the regulator is controlling at the set pressure. Next, remove the adjusting screw cap from the pilot and adjust the set point of the regulator to ensure that the regulator responds to changes in the set point. Then vary the flow rate through the regulator from a high flow rate to a low flow rate while observing the outlet pressure gauge. This ensures that the regulator is responding to increases and decreases in flow and controls at the set point. To verify shutoff, remove the closing cap from the pilot and back off the adjustment screw until the FlowMax reaches a 0 setting. This closes off the pilot and regulator. You can then open the downstream vent valve and blow off the pressure in the downstream system. Once the downstream system has completely vented, check for any leakage through the vent valve. To verify lockup pressure, establish flow by opening an outlet valve or vent valve to establish a small flow. Check to make sure the regulator is controlling at the set point. Close the outlet or vent valve and observe the outlet pressure gauge to ensure that the pressure does not go above the lockup pressure of the pilot. Wait an appropriate length of time to ensure that the pressure does not build up over the lockup pressure. If the pressure builds up, that would indicate a leak. Now let's move on to disassembly and internal inspection. Remember to make certain that the pipeline pressure has been shut off and vented before beginning any internal maintenance work. Disconnect actuator control, sense, and pilot supply lines to the actuator. Remove the pilot closing cap and back the adjustment screw out to remove tension from the pilot main spring. Disassembly and maintenance of the pilot will be covered in the Series 20 pilot training video. Loosen and remove the cap screws, securing the actuator housing, and remove the actuator from the body by lifting straight up. Do not pry. Remove the cage, seat O-ring, and body gasket. Note that the 6-inch FlowMax does not have a body gasket. Inspect the seat for damage. Replace as necessary. The cage needs to be unscrewed for removal. The housing O-ring should be removed and inspected. Remove the lower stem nut and remove the plug assembly. When removing or tightening the stem nut, use a wrench on the stem flats to prevent the stem from rotating and damaging the main actuator diaphragm. Inspect the plug seal and the plug O-ring for damage or wear. Replace as necessary. Remove the stem bushing from the bottom of the lower actuator housing. Use caution to not damage the sealing surface of the stem. Inspect the stem O-ring in the internal groove of the bushing for wear or damage. Now let's cover the partial assembly for stem plug seat inspection. Reinstall stem bushing snug tight. Do not over torque. Lightly lube O-rings before installation. If the O-rings have been removed, reinstall the bushing O-ring and the stem O-ring. Screw the stem bushing into the bottom side of the lower actuator housing until the bushing flange has bottomed on the housing. Do not over tighten. Install a new O-ring in the internal plug groove. Install the plug onto the tapered end of the stem with the plug seal facing away from the actuator. Screw the stem nut on the bottom of the stem with the rubber seal toward the plug to lock the plug assembly in place. Use a wrench to hold the stem flats and stem while tightening the stem nut. Ensure that the seat bore in the body is clean and install the seat O-ring and seat into the bore in the body. Make sure that the chamfered edge of the seat is resting against the seat O-ring and that the knife edge sealing surface is facing up. Install the cage onto the seat. The cage should fit snugly over the raised lip on the seat. Do not damage the seat sealing surface when installing the cage. For the 2-inch, 3-inch, and 4-inch FlowMax models, install the body gasket. The 6-inch FlowMax does not use a body gasket. Line up the mounting holes in the body with those in the lower actuator housing, and make sure that the loading port in the lower actuator housing is facing towards the front of the regulator. Apply a light coating of lubricant to the housing O-ring and lower the actuator assembly onto the body. Use caution not to pinch the housing O-ring during installation. Incrementally tighten the body cap screws to specified torque values. The gap between the actuator and body should be approximately 1/16 of an inch. The 6-inch FlowMax does not utilize a body gasket. There should be no gap between the actuator and body. Reconnect the Series 20 pilot, control lines, sense lines, and pilot supply lines to the actuator. Now we'll cover the installation of reduced capacity trim. Disconnect the actuator control, sense, and pilot supply tubing. Remove the cap screws securing the actuator housing and remove the actuator from the body by lifting straight up. Do not pry. Remove the stem nut. Use a wrench to hold the stem while loosening the stem nut. Replace the plug retainer with the reduced capacity plug retainer. Use a socket wrench to tighten the stem nut back onto the stem. Use a wrench to hold the stem while tightening the stem nut. Reassemble the actuator onto the valve body as shown earlier. Next, we'll discuss proper cleaning. Do not clean O-ring grooves with sharp metal tools. Use a cloth and solvent that is compatible with nitrile-based rubber. Wipe off the body, paying special attention to the O-ring groove. Rust can be removed with emery paper, after which use the rag and solvent again to clean any residue. After cleaning, allow the parts to dry and reassemble the regulator. We'll now cover troubleshooting tips for some field issues that you might encounter. The first steps in troubleshooting your FlowMax regulator should be: verify that the regulator specifications fit the application conditions. The minimum and maximum inlet pressure, control pressure range, and minimum and maximum operating differentials should be checked to make sure the valve and pilot are designed to operate in the present conditions. Verify the regulator is piped properly. Check that current piping connections match the recommendations shown in the installation, operation, and maintenance manual. Verify the regulator is sized correctly. Regulators operating below 10% or above 80% of their maximum capacity, given current application conditions, tend to have more problems. The following are a few of the most common trouble conditions and possible solutions. See the IOM manual for more details. One problematic condition that you might encounter is where the regulator will not shut off bubble tight in the PRV configuration. One way to isolate the source is to adjust the pilot set point to 0 by relieving the pilot spring pressure and then vent the downstream pipeline to atmospheric pressure. Remove the sense line between the pipeline and the actuator housing. Using leak detector, determine whether the gas is coming from the actuator sense port or the pipeline port. If gas is coming from the pipeline, the leak could be from the regulator plug seal, plug O-ring, or seat O-ring. See the IOM manual for more details. Another possible problem is the regulator will not open. Check to make sure needle valves are not used on any pilot system connections. Full opening type valves are recommended. Check if any valves in the sense line are not fully open. Check the pilot sense location. Check that existing piping matches the piping schematics. Check for binding. Check the main diaphragm for damage. Next is erratic behavior. Check the size and location of the sense line away from pipes, fittings, and other turbulent locations, and refer to the recommendations in the IOM manual. Check for damage, debris in the restrictor and control pilot. Replace, clean, and lubricate components as necessary. Consider pilot supply filtration with a Mooney Type 30 filter. Check if any valves in the sense line are not fully open. Check the pilot for excess friction or sticking. Check for excess friction in the actuator. This concludes the basic principles of operation, installation, maintenance, and troubleshooting for the FlowMax Regulator training video.